Hello everyone, my name is Amponsa Adam Isaac, and today I'll be demonstrating the Ghana agricultural field boundary detection. So for this application, the key part of our solution is that we'll first upload a TIF extension file, also known as the GeoTIFF. So unlike normal JPEG or PNG files, these GeoTIFF images contain spatial data. Spatial data meaning that they contain very real world like information in them. And in our case, what we want to do is that we'll first upload the file and then we will be able or we'll try and be able to do some predictions on those images or on these files. Since these files contain some kind of data set, we'll want to do some predictive analysis to them. And so for this demonstration, we will be using the Ghana maize production for 2024. And based on that, we'll do some field boundary detection. I want to also talk about how difficult it is for most farmers or most people in general to understand how these .tif files even work like. So the whole purpose of this demonstration or this application is be able to make meaningful visualizations for these files so that farmers or anyone interested in agriculture will understand what is going on, and then based on how our application works, they will be able to make meaningful decisions which will impact how production will be done in the other years to come, since we are using 2024. So if our predictions go very well, it might give farmers an informed decision to increase their productions in the years to come. And so first we'll start by uploading the file. I have a file called Ghana Predicted Maize Production, which was for 2024. So once I upload the file, it then does some data visualization for us. So this is the original production data which the file contains. And so based on the kind of detection method, it will explain why it did that, and then based on that, it will generate the number of fields for us. So first of all, we'll be using the watershed method. So for this watershed method, it was after the whole visualization is done, we have another section which will detect how many fields. So here we have 40 fields, 26.51 hectares, and the average field is 0.66 hectares. And the method is the watershed. So based on the type of detection method, then we'll be able to generate informed data for it. Then we have another graph which shows the distribution of the file sizes. So based on the kind of detection method, so we have k-means, another way of detecting. It does some data analysis, and then based on that, it also makes informed decisions. So here we have 74 fields for threshold. A different kind of graph shows, and then we also have different number of field detectors. So this is 93, and we have contour, which is also a different way for detection. And here we have 5 fields, and then there's a graph. So based on this, the farmer or the individual can decide to download the boundary map, download the statistics, or generate a report. So this is important so that the farmers will be able to make very informed decisions about what is going on. Thank you so much for listening to me.